Hi, I'm Justin McLouth.
And I'm Robert Herkenham, and for our EECS 373 project, we built a dot matrix printer. Okay, so this is our dot matrix printer system. It consists of 3 different parts: the screen, which has a menu system on it, the controller, which is an NES 8-bit controller, and then our actual printing mechanism itself. So what this system is able to do is it is able to take pixel art that's from a computer, 8-bit pixel art, and print it into a couple different photos, as you can see here, such as like a Block M, Stormtrooper mask, Mario, or Mega Man. And so the way this works is we have 7 preset options that are pre-created, pre-drawn, and you can select any one of them using the controller. So Start will allow you to print Mega Man, Select will allow you to print Mario, etc., etc. And by choosing what print you want to do, you could create the image. So I'm going to go ahead and show you an example. Let's print Mario. So turn on the power supply, and then press Select, and then the printing will begin. And here's a finished product of Mario after being printed.
Alright, so in addition to the 7 preset artworks that we have built in, we also have a draw your own function. So we'll demonstrate that now. So we'll start by pressing down, and then this is going to bring up the custom artwork screen, and we're going to use the D-pad on the Nintendo controller to draw your own artwork like Etch-a-Sketch style with a straight line. So I'll show you a quick demonstration here. And if you don't like your drawing, you can also clear the screen at any time by pressing Select. But if you like your artwork, we can turn the power supply here, and then press Start to start printing our custom artwork. Alright, and there's our drawing.
Okay, so now we're going to go ahead and show the actual technical system and how it actually works. So we have access to the XY plane using 2 stepper motors, this one and then this one, the second one being harvested from a CD drive. This allows us to get pretty accurate precision to draw each pixel. These 2 stepper motors are controlled through H-bridges, which are then serviced through the Smart Fusion, and this is how we are able to turn the steps and get this precision. Mounted on top of the CD drive stepper motor is a servo motor, which allows us to actually do our pen mechanism up and down, drawing the pixels. And this is controlled using pulse width modulation through the Smart Fusion as well. And this will give us the up and down angles to draw or not draw.
Alright, and lastly we have the user interface for our printer. This is going to consist of an LCD screen and a Nintendo 8-bit controller. So the LCD screen is controlled through a UART serial connection from the Smart Fusion. On here we display the menu for selecting which art form you want to print, as well as the printing progress screen and the draw your own function. Next we have the Nintendo 8-bit controller. On the Smart Fusion we programmed Verilog hardware on the FPGA to sample the buttons from the controller, and then when a corresponding button is pressed, that's going to generate an interrupt and then tell software to start printing the selected art form or enter the draw your own function. So that concludes our EECS 373 project. Thanks for watching.